Okay, so last week we looked at the role of diversity and how diversity adds value by bringing different opinions, and also looked at how some people can seem to get a better record than others simply by look alone. That be it making forecasts, making decisions, offering some advice, that by true look alone, some people will appear better than others. So what happens then is that to a certain extent, people can get fooled by randomness. People can buy into a particular individual, and you get what's called the seer-sucker theory. That there are suckers out there willing to believe in the existence of seers. So there's no real evidence to suggest that there are such experts out there. That what you should in fact do is look for a range of opinions across a wide group of people, and look perhaps for the average of those, rather than looking for one best individual. What today we're going to look at is how this averaging principle might work. How can it come about if you just ask a random group of people, or even ask people who might be informed? How can mindless signals lead to collective intelligence? How can you separate the information from the error? So we looked at this with the regression to the mean, that if the errors are made in opposite directions, they will tend to cancel out, and the information will emerge. The information builds and accumulates, and the errors tend to cancel. So information aggregation models make three assumptions about what people know. People know the answer with some probability, people know the pieces of the answer, or people get blurry signals of the answer. But there is some information there. Either they have some belief about what the answer they have, it might be true. Either they know that they have a bit of the answer, or that they have disparate bits that can perhaps be put together. But in order for the model to be able to work, we must assume there's some information out there. If you add up garbage, all you're going to get is garbage. So there must be some information to begin with. So the process of information aggregation allows the people who know the answer to reveal it, or aggregates parts of the answer to reveal it. So it either isolates the individuals who know the answer, or puts together the pieces that maybe people don't even know that they are aware of. And this goes back a long way, back as far as Aristotle writing in ancient Greece. So for each individual among the many has a share of excellence and practical wisdom. And when they meet together, just as they become in a manner one man who has many feet and hands and senses, so too with regard to their character and thought. Hence, the many are better judges than a single man of music and poetry, for some understand one part and some another, and among them they understand the whole. So this is the opposite view that we started with when looking at the madness of crowds. Aristotle, thousands of years ago, maybe over 2,000 years ago, was arguing that yes, there is value in collective judgment. And in many cases we don't leave judgments down to individuals. You don't sit in front of a crime for a jury of one, it's a jury of 12. And there are many instances where group decisions are made. One of the more whimsical or light-natured is returning to the theme of game shows. So we looked at game shows for game theory. We can also look at game shows as sort of a practical experiment of information aggregation. So Who Wants to Be a Millionaire has a setting where the wisdom of crowds is tested. So each contestant has 3 lifelines. They have 50-50, where of the 4 options in any particular question, they can get 2 of them removed. So 50% of the options are removed, and they are left with 50%. They have Phone a Friend, where they can ring up an expert and present the question to an expert and ask them to make their choice. I think beforehand you have to give the names of 3 people. So clearly you try to give it across a range of expertise and trust in them to provide the right answer. Or the final lifeline is ask the audience. There's an audience of 100 people in the studio, and each of them have a handheld gadget, and they just press one of the answers. So these are the lifelines available. So the ask the audience lifeline gives us sort of an immediate experiment with the wisdom of crowds. So we'll take the previous question on the members of the Monkees, a pop group from the 1960s, one of the first sort of created pop groups that weren't really musicians but were more marketed and merchandise, and they generate huge sums of money, a bit like much of the music industry is now. It's not to say it's new. creation of bands and boy bands in particular has been going on for the guts of half a century. So the question is, who of the following was not a member of the Monkees? Peter Tork, Davy Jones, Roger Noel, or Michael Nesmith? So you're presented with that answer. And if you said, well, I'll ask the audience, well, what if the presenter said to you, well, you can ask the audience, but here's some information on the audience we know already. 7 out of the 100 people there know the answer. 10 can limit it down to 2 and know 2 of the Monkees who are listed. 15 know 1 person who's in the Monkees and might be able to pick amongst the other 3 answers. And 68 haven't a clue. Do you want to ask the audience? Less than 1 in 10 know the answer. Less than a third have any idea of the answer. 2/3 of this audience haven't a clue. Are you willing to risk whatever it might be, £250,000 on an audience where 2/3 of them admit they haven't a clue? They're going to press A, B, C, or D, but they're widely guessing. So how useful would this group be if the Ask the Audience lifeline was used? So in answering the question, we can assume the following. The 7 people who know the answer will give the correct answer. So they know what answer it is. Those people who have no idea, the 68 people who haven't a clue, will pick randomly from the 4 available answers. Those who know 2 of the Monkees listed will pick randomly from the 2 they're not sure about. So they can pin 2 of the names down. Doesn't matter which 2. They can pin 2 of the names down as being a member of the Monkees, but are unsure about the other 2. And those who know 1 member of the band will pick randomly from the 3 remaining answers. So that'll be the assumption we make about when they press the button. So thus, Roger Noel, the correct answer, he is not a member of the band, so the other 3 were. He gets 7 votes from those who know the answer. They press C because they know the answer. He gets 5 votes from those who know 2 Monkees. There are 10 people who can limit it down to 2 of the answers. So 10 people know they can eliminate 2. So they're left with Roger Noel and another answer. If we assume they randomly break between them, half pick Roger Noel as the correct answer and half pick the other remaining answer. Doesn't really matter what it is. They've narrowed it down to 2. So 10 people have Roger Noel and 1 other answer. Half of those pick Roger Noel, half pick the other answer. He also gets 5 votes from the 15 people who only know 1 Monkee. So they have it down to they have it down to 3. They can pin down 1 name and say, yes, that person is in the band, and they've 3 options left. So again, if we assume that they're randomly split between the 3 options, 5 go for Roger Noel, 5 go for one of the other answers they pick, and 5 go for another answer that remains. And finally then, Roger Noel will receive 17 votes from the crowd who haven't the notion. There's 16 there just randomly pressing the button. On average, a quarter of them will pick answer C. So we'll get 7 from those who know, 5 who have an idea, 5 from those who have a quarter of an idea, and 17 from those who have no idea. What will the person be presented to sitting in the chair? So after a couple of seconds has passed, the music has ended, and they go, well, here is the results of the audience. So adding the 7, 5, 5, and 22, 7, 5, 5, and 17 actually, it should be, make sure that adds up. It is 34, so that 22 should be 17. Gets 34 votes. So the 7 from the people who know, the 5 from people who have half a notion, 5 from those who have quarter of a notion, and then 17 from those who haven't a clue. Roger Noel gets 34 votes. If people randomise between the other 3 answers, they will each get 22 on the remaining 66. So A, B, and D will get 22. So that's what will be presented. So this is the graph that's presented from a crowd where 7 out of 100 know the answer. 10 have a vague idea. 15 have a small bit of an idea, and 68 haven't a clue. So what happens is the information begins to emerge, and it's up to nearly 34%, and the highest bar for the correct answer, even with so little information in the crowd. The fact that A, B, and D are just randomly getting people pressing the button, people who haven't a clue. There are a certain number of people pressing C because they have some information, and that information will aggregate and build up, and the errors will be split between the other 3. So even with such a small level of information to begin with, it does emerge, and you go and get a graph such as that. And you can imagine that they were fairly pessimistic assumptions, that assuming a crowd with 7 out of 100 knowing the answer, but in general you'd find maybe slightly higher than that. And that would cause the bar with the correct answer to be far higher. So it does suggest that it doesn't take many people for the correct answer to stand out. This is not to say that will always be the case. But in general, the dumb crowd chooses the right answer. In fact, they may be able to get it right if no one knows the answer. If it wasn't the case of 7 people knew the exact answer, if those 7 people even themselves only had a vague idea, that would also allow the true answer to emerge. So you can look and say, what is the outcome if everyone knows only 2 monkeys? So work out and say who gets the votes. If everyone can pin it down to 2 answers, in that case, Roger Noel will get 50% of the votes. Nobody knows the answer. Everybody knows that 2 of the names are in the band, and then they're left with 2. Which one of these wasn't in the band? They don't know. If they just randomly guess, Roger Noel will get 50% of the vote, even if no one knows the answer. So studies have shown that on Who Wants to Be a Millionaire, the audience got 9 out of 10 questions right, whereas the Phone a Friend lifeline was correct 6 out of 10 times. So the audience does appear to be better. This is not a scientific experiment. Clearly the audience and the expert weren't asked the same questions. Maybe it was that the audience and the expert weren't asked questions of the same difficulty. If you look, there may be a pattern in the way people use the lifelines. That early on they'll tend to use the 50-50. They have an idea themselves, want to get out of jail, they'll use 50-50. Then they'll save the Phone a Friend, ask the expert, and use the ask the audience. And perhaps maybe it should be the other way around. So while the ask the audience did get more questions right, we couldn't stand over that scientifically. They weren't asked the same questions, and we don't know were they the same difficulty, assuming the questions get more difficult as you go from €1,000 to €1,000,000. But there is a difference, a substantial difference, in the ones that get it correct. However, the crowd is not always right. The assumption we've made is that people choose randomly between one answer or another. If you watch the full version of Darren Brown's thing on horse racing, I'm not quite sure what the program was called, you'll see there's a clip in that where he shows him tossing a coin and the coin landing heads 10 times in a row. Even though you would expect it to be 5 heads and 5 tails, he has a clip where it lands 10 heads in a row. So there could be 10 people in the audience looking at picking one of 2 answers. You'd expect it to go 50-50, half to press A, half to press B. But it could be that just out of pure random luck, all 10 in a row press A. A tossed coin can come up heads 10 times in a row. There's no rule that says after a heads you have to get a tails. It is, on average, a coin will come up heads 50% of the time and tails 50% of the time. But that doesn't mean it'll happen all the time. So in the above example with the statistics and the assumptions about the crowd will pick an answer other than Roger Noel about 10% of the time. It could just be randomly that more people press one of the buttons than the other, that the errors don't cancel out, that the errors actually accumulate, that for some reason everybody picks A, that a lot of people who don't know the answer pick A for some reason. Just like a coin come up heads 10 times in a row, a whole row of people can pick A for no reason 10 times in a row. Or it could be that there's a correlated bias. There could actually be a reason that causes the crowd to pick one answer over the other. So members of the audience may copy those beside them. So look to their left and see a button being pressed, they press it, maybe the person keeps looking to the left. It's a common theme where an error will tend to accumulate. Possibly something that happens fairly frequently in multiple choice exams. That's not correct information flowing around, it could be incorrect information. Or it could be there was a previous question about sailing and seamen, and maybe people lead to believe one answer is a reference to Davy Jones' locker. So that maybe there's a theme in the questions. So maybe one of the earlier questions could have been about that and saying, well, he's talking about the sea, talking about the ocean. We'll maybe hear the references to Davy Jones and select that. So there can be biases that cause people to not randomly choose, but to be led or directed towards one answer or another. The example we used was on a purely random basis. with a 50-50 choice. Half went in one direction, half went in the other. That may not necessarily be the case. A tossed coin can come up heads 10 times in a row. And if you've watched the Darren Brown experiment, how long did it take? It took him a long time. He was tossing a coin into a bowl, I'd say, until he was at it for days. But he got there eventually. So in general, the correct information emerges and the incorrect information cancel out through randomness. Tossed coins don't come up 10 times in a row very regularly. However, this does not explain all instances of information aggregation. There is a thing referred to as the jelly bean experiment, where a finance professor in a university in America brought a jar of jelly beans into class and asked the class to guess how many jelly beans were in the jar. So simply plonked it up in front of the group and asked them all to provide a guess. Very much similar to the Francis Galton ox experiment. What insight or information could people have when a jar of jelly beans was presented above them? What insight could they have on the volume? What insight could they have on the quantity? What insight could they have on the density inside in that jar that would allow them to form an informed guess? And it's likely that with the jelly bean experiment, nobody knows the exact answer. Nobody's going to plonk up and say, when the jelly bean hits the table, I know the answer. Unlike in the Who Wants to Be a Millionaire, where some people will know the answer, in something like the jelly bean experiment, no one will know the answer. And again, even if no one knows the answer, the crowd can still be right. Again, because of the concept of regression to the mean. Some people guess above the true answer, other people guess below the true answer. We assume that people are giving some piece of information, that they might have some concept of size, weight, quantity, and volume that allow them to make a reasonably informed guess. Nobody would perhaps make the exact guess, but again, the information will emerge and accumulate, and as long as the errors aren't correlated, they will cancel. So this is with a situation of information emerging. So in Who Wants to Be a Millionaire, it's a bit whimsical. But 25 years ago, there was a very real example of information emerging quite quickly. So in January 1985, the Space Shuttle Challenger took off. So this is the live broadcast from CNN of the actual launch. So that was the launch as it occurred live. back in January 1986, or 1985, and clearly all members of the crew were lost. Might not seem humane or nothing, but after the launch and as soon as the disaster has struck, there will be an immediate reaction. And the most immediate reaction will perhaps be in the stock market, where concern may not be for the 7 people who have lost their lives. Concern may be for people's investment portfolios. So CNN was probably being played out live on the stock market floor, perhaps in New York and other areas around the world. But in New York, most of the main people involved in the space shuttle program were being traded. And space shuttle launches had become rather mundane at this stage. Back in the early 1980s, they were fairly significant events, but by the mid-1980s, they were seen as fairly routine. So it was unlikely there were many people watching it live at the time. The main contractors, the 4 main companies involved in the space shuttle program, were Rockwell International, who built the shuttle engine, the shuttle itself, the actual vehicle, and the main engines. Lockheed, who provided ground support, the huge unit that's used to hold up the space shuttle prior to launch. Martin Marietta, who provided the external fuel tanks, so the huge tanks which held the huge amounts of fuel required to take an object of that size and for a vertical takeoff. And Morton Thiokol, who provided the external solid fuel booster rockets. So these are the rockets that are attached to the side of the vehicle itself. So all 4 firms were quoted in the stock market, publicly quoted companies in which you could buy shares. So clearly the disaster would have implications for NASA contracts in general, and in particular for the company at fault for the disaster. So either the space shuttle project was going to be terminated, it was going to be delayed, and it was likely that a company at fault was going to lose a contract and lose heavily on reputation. That safety and the performance in the space shuttle project was paramount. So whichever company was at fault was going to suffer more than the worst. So 21 minutes after the explosion, so they've probably just seen a replay of what we've seen. CNN putting it on loop. This is what happened 10 minutes ago. Lockheed was down 5%, Martin Marietta was down 3%, and Rockwell was down 6%. So clearly the space shuttle program formed a fairly important part of the operations of these companies, and their shares were suffering accordingly, down 5%, 3%, and 6% in 21 minutes. If somebody gave you an investment proposal that earned 6% over a year, that would be a fairly generous rate of return. And one of the companies here has lost 6% in 21 minutes. However, there were so many investors trying to sell Morton Thiokol stock that trading was halted. So in a stock market, there are market makers. There are intermediaries who do the buying and selling. You don't necessarily buy off somebody who owns the share. The market maker, in a sense, makes the market. If you want to buy shares, you don't have to find somebody who owns them. Where do you go? Well, you go to the stand or the location for that particular share, and there's a market maker there. He's basically the shop. He has some in stock. So if you want to buy it, you buy it off him. But what happened after the stock market or the Challenger disaster was he wasn't finding people coming to buy, he was just finding people coming to sell. And in general, he will take them. The market maker will take and build up the stock, and then he'll find buyers and flog it off. He doesn't really care about the price. He's just looking at making the market. So he'll take it off one group and sell it to another. But what the market makers were finding was that all they had was sellers. That all that was building up behind them was huge piles of Morton Thiokol stock and nobody willing to buy. The other shares, we can assume there was people looking to sell, but perhaps there was somebody saying Rockwell down 6%. Well, that's actually an investment opportunity. They may lose something because of the Challenger disaster, but I actually think it's a fairly solid company and likely to bounce back. So the market makers for Lockheed, Martin Marietta and Rockwell were finding there were more sellers, but there were still buyers out there. So the market was functioning. For Morton Thiokol, there was just sellers. So the market stalled. So after perhaps an emergency meeting or something, figuring out what they would do, how much would they actually hold, maybe what margins would the market makers have to take, trading resumed an hour later. And by the close, the stock of Morton Thiokol had lost 12% of its value, more than double the loss of any of the other ones. And in fact, by the end of the day, the stocks of the other three had recovered. And they were down around 3%. So a 3% loss for the people involved in the shuttle and main engines, ground support and the external fuel tanks. The company which provided the solid fuel booster rocket was down 12%. What information did the stock market have to make that judgment? In the immediate aftermath, there was no information publicly available that laid blame in one area or the other. All that was available was the TV footage, blurry images showing the space shuttle exploding about 5 miles up into the air. From that, what could you infer? What had caused the explosion? Was it the engines in the vehicle itself? Was it a problem with ground support, as was the problem with a later space shuttle mission? Was it a problem with the fuel tanks? Did they explode? Or was it a problem with the external rockets? So the markets had no information. But the market had almost immediately labelled Morgan Thiokol as the company responsible for the Challenger disaster. Their share price had suffered the most. Media reports over the following days, within 21 minutes of the disaster, the stock market had pinned it down. Media reports over the following days said there are no clues to the cause of the accident. So even days after, there were no clues to the cause of the accident. 6 months later, a presidential commission revealed that an O-ring seal, O just being a circle, a seal on the booster rockets made by Morgan Thiokol had failed. That information wasn't revealed till 6 months later, and it was famously revealed by physicists Richard Feynman, Dick Feynman, who took one of the O-rings into the presidential commission when he was giving his evidence. As he sat down to give his evidence, he got the O-ring and put it into a glass of iced water in front of him. He proceeded to give evidence for the next few minutes, and at the end of one question, he picked the O-ring out of the glass of ice water and bent it. It had lost its strength because of the cold temperature, and he displayed that simply by dropping into a glass of ice water. On the day of the Challenger disaster, the temperature was below zero. So clearly the O-rings had lost their strength, lost their ability to serve as a seal on the day of the disaster, and they had failed. In the stock market, nobody knew anything about O-rings. Nobody knew what they were made of. Nobody knew that they failed in sub-zero temperatures. But there was some information out there that Morgan Thiokol was to blame. So individual investors did not know the cause of the disaster, but the overall market acted as if it knew. And there had been some suggestions, small rumours of problems with Morgan Thiokol, some problems with the O-rings, maybe why some of the previous takeoffs had been aborted, but there was no collective judgment out there. Nobody in the stock market stood up and said, the space shuttle blew up because the O-ring failed. Nobody in the stock market knew that. But the information of buyers, people acting on the basis of rumour, people acting on the basis of instinct, people acting on the basis of maybe something they'd heard, saw that information emerge. There was people who probably blamed the other three companies, but they were cancelled out by people who didn't blame them. There may have been a small number of people who blamed Morgan Thiokol, and that got, in a sense, exaggerated and developed out. In much the same way as it just took 7 people in a group of 100 to get the correct answer in Who Wants to Be a Millionaire, it just takes a small group or even a small piece of information in a stock market to get the correct information out. So nobody knew the answer, but the market did. And the method of aggregation was the price. In Who Wants to Be a Millionaire, it's columns in a graph. In a stock market, it's the price. How much are people willing to buy and sell at? And for Morgan Thiokol, they were only willing to buy at much lower prices. So the market was smart because it satisfied the 4 conditions of wise crowds. So each person's guess had some information and some error. There was a diverse group of independent people who had specialist knowledge, and there was a system there that would aggregate it. So averaging subtracts the error, and we were left with the information. So the price reflected the information. The averages cancelled out. Some people who didn't blame them, some people who did. On average, the information emerged. However, for this to work, there has to be information there to begin with. So there was some information in the market, but it wasn't there collectively. So with most things, the average is mediocrity. Average height, average intelligence, average speed. With decision making, the average is often excellent. But in most cases, the averages put you in the middle. With decision making, the average can put you at the top. The errors will cancel out. So the last element we look at is to do with predictions. So Yogi Berra, prediction is very hard, especially about the future. So information aggregation shows that group intelligence may be good at answering questions on quiz shows or guessing how many jelly beans are in a jar. So we need to know how it performs when the right answer is seemingly unknowable. Right answer is seemingly unknowable because it hasn't happened yet. So we're going to look at collective decision making when faced with uncertainty. So there is a correct answer to who isn't a member of the monkeys. There is a correct answer to how many jelly beans are in a jar. There is a correct answer to who is at fault for an accident that has happened. But what about something that will happen into the future? If people are asked to predict what would cause a space shuttle disaster, would they have got the right answer? So we'll consider a situation where 3 pundits predict where teams will finish in a football league at the end of next season. So our 3 pundits are John, Liam and Eamon, and our 3 teams are Chelsea, Everton and Newcastle. So the numbers opposite each name are their prediction for where that team will finish. So John has a prediction of 5th for Chelsea, 6th for Everton, 3rd for Newcastle. Liam then has a prediction of 3rd, 5th and 8th for the 3 teams, and Eamon has a prediction of 1st, 10th and 7th. So this is the prediction made by these back in the middle of August, before a season commences. If you look at the average prediction, what is the prediction of the group? Bill O'Hurley asked them their individual predictions and then was quickly able to work out, well, as a pundit team, this is what you're saying. For Chelsea, there's a prediction of 5th, 3rd and 1st. Add them up, there's 9. Divided by 3 pundits, you get 3rd. So the average prediction for Chelsea is 3rd. For Everton, 6 and 5 is 11 and 10 is 21. That's an average prediction of 7th. And for Newcastle, 3 and 8 is 11 and 7 is 18. Divide that by 3, again, average prediction of 6th. So the average prediction was 3, 7 and 6. If we just guess and say what's the actual outcome that would be, we'll just say that it doesn't really matter. Chelsea finished 1st, Everton finished 6th, and Newcastle finished 5th. So at the start of the year, who should we turn to? Is there one best pundit? Or should we look to the average? Is the average mediocrity, or is the average excellence? Well, we need to look at the errors that they make. What deviations do they make? And one thing we must do when looking at errors is square them. To see the total error that somebody makes, you must square the errors. If you just add up the errors, negative errors cancel with positive errors. So a pundit could over-predict one team by 10 places and under-predict another team by 10 places. If you add up those errors, plus 10 and minus 10, you'd say that pundit made no error, spot on. And that's clearly rubbish. He was out by 10 places for one team, out by 10 places for another team. So to avoid the errors, positive and negative, just cancelling out, we square them. So that means that they're cumulative, they add up, they're not cancelling out. So the distances are still important. The square of 10 will be greater than the square of 2. And it does give us an indication of the level of errors being made by an individual pundit. So we'll calculate the square errors of the pundits. So this is the sum of the actual minus the expected. So the errors here are 5, 6 and 3, which is the guess of pundit John. We have 3, 5 and 8, the guess of pundit Liam, and 1, 10 and 7, the guess of pundit Eamon. And then you have the actual outcome. 1st for Chelsea, they predicted 5, 3rd and 1st. 6th for Everton, they predicted 6th, 5th and 10th. And 5th for Newcastle, and they predicted 3rd, 8th and 7th. So look at the errors they made. So 5 minus 1 is 4, 4 squared is 16, 6 minus 6 is 0, 0 squared is 0, and 3 minus 5 is minus 2 squared is 4. That's 16 plus 0 plus 4 is equal to 20. For Liam, you have 4, 1 and 9, so 4 and 1 is 5 and 9 is 14. And for Eamon, you have 0, 4 4s are 16, 2 2s are 4, 16 plus 4 is equal to the 20. So that's the errors of our individual experts. So which expert is best? Well, in this instance, this is just a random sample or a hypothetical example, it was Liam. His squared errors summed to 14. On average, his guesses were closer to the actual outcome than the other two. And the average sum of the squared errors is 18, just almost 18. 54 divided by 3. What is the average individual error? How close are the individuals on average? So we have 2 20s and 1 14. The average is pretty close to 18. What about their collective prediction? If we asked the 3 of them their predictions and got their collective or group prediction. So this is 3, 7, and 6. So here you have 3, 7, and 6. And you have the actual outcome. First for Chelsea, 6th for Everton, 5th for Newcastle. In this instance, the collective error, 3 minus 1 is 2, 2 squared is 4, 7 minus 6 is 1, 1 squared is 1, and 6 minus 5 is 1, 1 squared is 1. So we have 4 plus 1 is equal to 6. Their collective prediction is more accurate than any of the individual predictions. 20, 14, and 20, they're individual errors. 18 was their average individual error. Their collective error was 6. Their collective prediction was better. So this is because of diversity. Because they all made different predictions. If they all made the same prediction, if he asked John, Eamon, and Liam what their prediction for a particular team was, and they all said the same answer, well, you may as well just have one of them there. What is the point in having 3 people sitting there if they all say the same thing? In order then for the collective or group prediction to be more accurate, it requires diversity. So this is because of diversity. When one predicts too high, another predicts too low, and their mistakes, while not cancelling entirely, become less severe. So again, the average moves towards excellence rather than mediocrity. So the issue is based on prediction diversity. How different are they actually? Are they all very similar? Or are they all very diverse? Is there much diversity in the group? So prediction diversity. How different are they? So this is based on the square distance from the collective prediction. So the first number here is now the individual prediction. So John has 5th for Chelsea, 6th for Everton, 3rd for Newcastle. The second number is now the group or collective prediction. The group predicts 3rd, the group predicts 7th, the group predicts 6th. So the issue is, how far is the person from the group? Are they all very similar? If they all predicted the same thing, their individual and the group prediction would be the same. If they all said Chelsea would finish 3rd, clearly the group prediction is that Chelsea finished 3rd. The individual prediction is that Chelsea finished 3rd. There is no diversity there. What you want is a difference between the individual and the group. So this measures it. The greater the prediction diversity, the greater will be this measure here. So for John it's 14, for Liam it's 8, for Eamon it's 14. So the prediction diversity is the average of these. So 14 and 14 is 28 and 8 is 36. The average is 12. So the average prediction diversity, how distant are they from the group prediction? Are they all very similar? So there is some diversity here. Again, this is a contrived example. This is not based on any reality. It's just imposing numbers. So we now have a couple of measures. We have the collective error. How close is their collective prediction to the actual outcome? That is 6. We have the average individual error. On average, how close were the individuals to the actual outcome? That's 18. And we have the prediction diversity. How different were their individual predictions? And that's 12. There is a theory, or a theorem, or a fact of predictions, of collective predictions, and it's that collective error is equal to average error minus diversity. That equality always holds. That is always true. If you plug in different numbers, and you should plug in different numbers into that example, put in different predictions, put in different outcomes, and then work through the different stages, get the collective error. How close are they on average? Get the average individual error. How close are they individually on average? And then get prediction diversity. How different is the group? Collective error is average error minus diversity. So what does this mean? Well, this means the group the collective error is always lower than the average error unless diversity is 0. The prediction of the group is always better than the average error of the individuals unless diversity is 0. And the only way diversity is 0 is if they all make the same predictions. And if they all make the same predictions, well, there's no value in asking the group. They're all saying the same thing. So because of diversity, the collective error will be smaller. The group will reach a better outcome. And this always holds. Plug in different numbers into that table. Make different predictions for the 3 pundits. Plug in different outcomes and work through the 3 stages. And you will get to this situation. You'll have different numbers, but you'll find that the collective error of their aggregate judgment will be lower than the average error of their individual judgments. The group is smarter than the individual. So individual ability measured by individual error and collective diversity contribute equally to collective predictability. So it's not simply good enough for a group to, in a sense, be good. The group must be different. The 2 elements you want are people who have information, and we assume these people have information, and then you want them to be different if you want to use the group decision. So in a group, being different is as important as being good. If you come into a group and you're good, but you're equally as good as somebody who's already in the group, what are you offering? The information you're offering is already there. What the group needs is diversity. It doesn't need to suffer from groupthink. So unless there's no diversity, the collective error has to be smaller than the average individual error. The average estimate of the group will have a lower error than the average individual error of the individuals. And that's from some readings by Scott Page, which are up on Blackboard. So leave it at that for today, and we move on to specialization and aggregation, on Friday.